Hey guys, ScannerDanner here at my brother's shop as usual with my son behind the camera as usual. Today we're working on a Hummer. What year is the Hummer, Danner?
It's an H3.
H3 Hummer that has, what's the customer complaint?
Bunch of check engine lights, loss of throttle response, sometimes more than others, goes into a complete limp mode.
Someone put a throttle body on it too?
Throttle body's been on it, accelerator pedal, position sensor's been put on it, a couple other sensors, I'm not sure.
And you said you scanned it and you saw
I
like...
never even scanned it yet. I was just going by what he told me, and I asked him specifically, I was like, do you have any reference codes? He's like, yeah, I got a 5-volt reference code. So
okay.
I mean, he's chasing a shutdown probably of a 5-volt circuit that's killing.
Yeah, and I was saying to you yesterday that we've done one of these where we had a shorted 5-volt reference on that one stud that ran across the valve cover on a
V8 Chevy.
Yeah.
Liter,
And what engine's in the Hummer? That's not the same engine, is it? The H3, or is that 5-cylinder?
I'm not sure. To be honest, I'm
all right. Well,
prepared to talk to you, man.
All right.
I have no idea.
Well, you do your.
I know that he would have to actually physically clear the codes for it to come back.
To get it out of limp mode.
Yeah, sometimes he could turn a key off and it would drive again, but
yeah.
sometimes he'd actually had a little cheap Harbor Freight tool and he would actually have to clear the codes to get it to move again. So
well, hopefully we can duplicate it and make it.
I want to say he's been doing that for a while too. I mean, changing stuff.
Yeah.
I don't know if it's like a personal vehicle or if I'm not.
Well, remember that other Hummer we did? We have a video on it too. I think it was a voltage problem to the relay. Was it a broken wire in the power distribution box or something?
I think that was like a fuel pump area issue though.
No, it was setting limp faults and low voltage to the throttle body, and it was a faulty relay, I think.
It was the socket. Oh yeah, the relay. You took it apart. It was corroded in the terminals, but it also wicked up into the relay.
Yeah, maybe that's what we have going on with this one. Let's go find out. Come on. No. No. Come on. The unlock button wasn't working on the key fob. All right, so it's 2007 Hummer H3. It's a 3.7 liter L5. I think that's the straight 5-cylinder engine. Let's do a code scan. I do have a check engine light that is on right now. EVAP vent control. APP sensor 1-2 correlation. EVAP system vent control. APP 1-2. So those are the same codes in the engine and transmission. Nothing in the ABS. Current history for the ABS. PCM traction control not allowed. Lost class 2 communication with ATC. Lost communication with ECM, PCM, VCM. Lost communication with BCM. Those are the ones that we're going to be attacking. Body control module has class 2 data high or low volts. Generator battery control module says refer to OEM repair information for code description. Class 2 data high or low. Yeah, this is going to be a network fault. I'm not worried about the EVAP vent valve problem. We're not attacking that today. That's an easy one. That's going to be wiring or the solenoid itself. So at this point, given the symptoms, we have a pre-scan and it saves it for us in the scan tool. I'm going to clear all these codes and we're going to go drive it. And we're going to hope we're able to duplicate it. All right, no codes in anything. We'll go to the engine, being that we had an APP code. We'll go to our TAC data, that's throttle actuator control. I don't know if I want to customize this or not. So these two guys, I mean, we can kind of watch the TPS 1-2 agree and the APP 1-2 agree. Does this have reference voltage here too? Yeah, ref 2, ref 1. We'll kind of look at those guys. Given we had voltage issues with the last Hummer that we worked on, let's graph that too. Ignition 1. Okay, I don't see any other battery voltage ones in this list, so we'll go with what we have. Just kind of go with this list for now. Why is my check engine light still on? Read that code real quick. Probably the vent valve is my guess. Yeah, vent valve control circuit low. Computers are pretty smart. It knows there's a open circuit most likely on this valve, and we're setting this code 449. I'm not worried about this. We're not attacking this code. Initially, this has nothing to do with the symptom of limp mode and the throttle body being replaced and all of those symptoms. So we're not attacking this vent valve code, at least not at this point. We may, if we can get this thing to act up and pinpoint it pretty quick, we may do something like that where we look at the vent valve, but I do that a lot, don't I? I say but, and I never finish my thought.
Yeah, you do. I don't know if you all know that because I cut it.
Probably makes.
Then
it's just like but.
The main issue with
what?
it is if I leave in you saying but and then nothing happens, you ask me, what did you just cut out of there? And I say nothing. Yeah. You don't believe me.
I know. I'm sorry, Caleb. I should probably finish my thought when I say but.
Because it's either that or you'll finish the sentence like 5 seconds later and the audio's all off.
I know. I'm so sorry. I don't know what else I want to look at here. Definitely interested in my ref voltages and my ignition voltage. Intermittents. Gotta love them. I'm gonna change my scales here in a second just to make this better viewing for our community. It looks like we had a voltage change before we even got started, like almost like while I was setting up the ScanDanner lists, this reference to circuit. So these are self-updating min-max scales. I've said that a ton as we're looking at ScanDanner. Look at the min scale on Ref 2 is 3.98 volts, but I didn't see that drop. Where in this data list? Yeah, it never did the whole time I started that. So just a tip for you guys on the Snap-on ones, you can change the scales and see, they changed the program on me. Hold on, let's see. Oh, the 3 buttons there. Setup, trigger, auto scale. So we don't want auto scale. We'll go max in case it goes high. I'll just do 10. And minimum of 0. Save. And then we'll do the same for this one. The only reason I'm moving the voltage up is in case we have a bad ground, voltage is gonna rise above 5. And then that just helps our eyes. It helps Caleb in the edits too. It helps everyone on the test drive. You know, you can do the same thing with voltage too. If you don't wanna see that wavy up down line, you can do your setup where there is, we'll go 16 volts as a max and 0 volts as a min. Nice steady line in comparison. And that allows you for easier viewing. If you're by yourself and you're driving, to see any glitches or dropouts will be more pronounced. Not that real tight auto min-max scale. So let's see if we can break this thing. These things are gutless. That was wide open throttle. I mean, it's not bad, I guess, considering it's a little 5-cylinder, but I was never a fan of this inline 5, if that's what this is. Maybe it's not. Maybe I'm speaking out of turn, out of line. Come on, man. We don't want to have an intermittent day. Yeah. Intermittents suck. Everything we've been looking at lately has been network issues and intermittents.
When's good old EVAP?
Yeah, or no. I was thinking like what happened to good old no starts, where it's cranking and not starting. When's the last time we've done one of those? Or a misfire. When's the last time we've done a misfire? It's all been network and communication faults and intermittents. But we're learning a lot. and we're gonna teach you guys as we learn too. That's me. I'm just trying to get some drivetrain torque, kind of simulate, you know, what we did on the Caddy. We just looked at a Cadillac yesterday. You guys will see it at some point in time. That one was fun. Cadillac CTS. I will say no more. You'll have to watch it. Can't fix what ain't broke. I need to see it do it. We could look at, you know, the fuse box and that relay like the last Hummer we worked on. We can do some inspections on that front, but without seeing it do it, I really don't know what I'm looking for. So it's kind of hard to do visual inspections. Like, do we focus on harnesses or components? It's kind of what I'm getting at. Without having some direction, I don't know what I'm looking at. I needed to do it. That's me, like, not finishing my sentence again. Thanks for picking up on that. It'll help you in the edits.
It's when you see something that like piques your interest.
Yeah, I guess doing a wide open throttle run right past this elementary school is probably not a good idea.
Oh, where are we?
Yes,
we were here when this line was painted.
Yes, on that Hyundai with the bad mass airflow sensor.
Is that what it was?
Yeah, it was a bad MAF that was setting throttle body codes. This isn't what I want to do today, Caleb. I'm not, you know, one of the things that's difficult with these types of situations is, what do you do if you can't duplicate it? Now, we could spend some time and research the codes that were in here and look for TSBs. You know, that might be a fruitful approach, but, you know, for the garage owner, for you guys that are doing this and you're not, you know, getting paid by the video like Caleb and I do, you know, what do you do? How do you charge? There are times where you proceed and there are times where you don't. There are times you give the car back to the customer, let them drive it, tell them to bring it back when it does it more often. It also helps to communicate with your customer and find out when it does it for them. And also their driving habits. Are they a heavy foot driver, a light foot driver? Back in the day, you know, working in the field full time, if I saw like a Kleenex box in the back window, then I would know to drive it lightly because it's an old person. So little things you learn and, you know, tips, tricks along the way. If you see like, you know, some, you know, deadhead sticker or something on the back, you know, some young punk kid, then you might want to drive it a little bit heavier foot, you know, that's just if you can't get in touch with a customer. But those are things you want to ask your customers. When does it do it? How do you drive? All stuff to help identify and recreate intermittents. Sometimes I'll look for a road where I can put the right front tire like up on the curb like this, you know, where I'm just trying to hit some bumps, you know. I want to simulate like vibration. And so I'm intentionally looking for like areas where I can just get a little bit of driveline vibration. We certainly want to be careful, but this will be our final loop and then we'll go back to the shop and tell Danner good luck. It's hard to stop for us sometimes because we have, you know, 3 feeds going right now. We have a mic synced up, we have a screen recorder synced up, we have the camera synced up, and we don't want to stop because it's like we wasted our time. But Danner's parking lot, it's always full. Perfect timing. Got Danner out. Can't make it do it, man. No.
Codes in there?
Yeah, well, there's a bunch of codes, but I got an EVAP vent valve fault that's a hard fault, but I ain't worried about that one. No. The check engine light's on right now from that. It's a low voltage code. It's probably a bad solenoid or broken wire right at the connector, but I can't make it do it. What do we want to I don't know. I guess I'll do a visual inspection and look at things under the hood, but
what are you doing?
I'm just going to pull this report up real quick just to see what codes we had in here. Okay, I really like this. I haven't used this a lot. I really like the PDF reports. It's real easy to read. Makes it nice. I just got done saying I like these reports. Yeah, when they load, oh my goodness, here we go again. It's like Adobe like interfering with me Come on, man. Stop being stupid. No, I don't want a free trial. All right, P2138. We can look at those. And then these U codes, U1301. Remember that, U1301 I want to look at, and the P2138. Well, we'll have to leave that open. We'll bounce here. P2138. This is in the scanner troubleshooter. It says sets when the voltage difference between APP1 and 2 exceeds a calculated value. APP1 at rest position should be near 0 volt and increase as pedal is depressed. APP2 voltage at rest is near 5 and should decrease, so they go opposite of each other. That's exactly what it does. Some customers may comment on intermittent malfunction indicator lamp illuminated with message indicator that displays engine reduced power. That's us for sure. Technician may observe on the scan tool a P2138, correlation, current, or history. Oh, this could be good. This condition may be caused by water intrusion into the instrument panel to body harness connector, which carries the APP sensor signals to the ECM PCM. This is a huge tip. This water intrusion results in voltage difference between APP1 and 2 that exceeds a predetermined value for more than calibrated period of time. Now we have to correlate that also with the U codes we had. Correction, note, aftermarket equipment can generate the P2138. Verify aftermarket equipment is not electrically connected to any of the APP sensor signal or reference low circuits, or to any other ECM, PCM 5 volt reference or low reference circuits. So we have an aftermarket radio, but that's not going to be the case, I don't think. Perform diagnostic system check. If any 5 volt ref DTCs are set, refer to that. If any 5 volt ref DTCs are not set, proceed to step 3. We didn't have that. Locate the IP body harness connector, which may be located in and around the left kick panel area or inside the IP instrument panel, depending on the vehicle and model year. Refer to schematics. Some examples of water leaks are A-pillar seals, sunroof drain lines if equipped, windshield cowl sealing. Inspect for water leak in the area. If necessary, use a water hose to determine source of the leak. If water leak is observed, repair is necessary. Inspect the IP2 body harness connector terminals for corrosion. IP2 body harness, all right. Refer to testing intermittents. If any corrosion and debris is observed. Yeah, all right, but that's a pretty good tip for that. It will be worth looking in this left kick panel area before I do anything else based on that code. We're gonna do that, U1301. So this is the description for that. This is in the BCM. Modules connected to the class 2 serial data circuit monitor for serial data communication during normal operation. Operation information and commands are exchanged among the modules. In addition to this, node alive messages are transmitted by each module on the class 2 serial data circuit about once every 2 seconds. When the module detects high or low voltage on the class 2 serial data circuit for approximately 3 seconds, the setting of all other class 2 communication DTCs is inhibited and the DTC will be set. Conditions for setting class 2 serial data circuit shorted, high or low for approximately 3 seconds. Conditions for running the DTC is voltage supply to the module is in the normal range. The vehicle power mode requires serial data communication to occur. Diagnostic aids, DTC cannot be retrieved with current status. Diagnosis of current DTCs is accomplished via the symptoms. Scanner does not communicate with class 2 device. So that'd be if we wanted like the flow chart. Intermittent condition is likely to be caused by a short on the class 2 serial data circuit. Yeah, not a whole ton of great help there. And I believe the class 2 serial data is just the CAN network on this. I'm pretty sure. It's GM's name for it. Let's go back to the troubleshooter under the engine. See if we have some other tips. Test the alternator for AC voltage leak affecting the PCM operation. Measure AC voltage at the alternator output. I did notice there were some fluctuations in that line, but I don't know that this has those symptoms. There's other stuff in there too, but we can't forget about the alternator always. All right, I guess I'm just gonna look in this kick panel area and then maybe take a look under the hood and do a couple other checks. We might be done with this for now. That tip for water intrusion is pretty cool. Wet? It sure is. It's not soaking wet, but it's wet. And it is winter time, so. That's dry. Let's go take a look under the hood. I'm giving this one back to you, Danner. Say good freaking luck. How long do they drive it for it to not act up? Happens a lot. That could be like once a week. Let's look in this fuse box. Last timer we looked at, I don't remember which one was corroded, and the last one we messed around with. So they wired in a new throttle body and connector. We'll shut this off. Stay there. I'm just looking for corrosion in the box. We have it. There it is right there. Me unplugging these relays is not a good idea though. Danner, come here, check us out. I didn't unplug all of them yet, but I mean, we have evidence of the same thing that last timer had. I don't know which relay that is. I should probably know before I start pulling them all.
I'm just wondering, yeah, we got to look at like
60s and 70s, so from 60.
Where do you draw the link though without a code? Like, I don't know which codes were in there.
Well, I have the codes saved.
Oh, there were some like APP and TPS codes, 5-volt reference codes?
No 5-volt ref codes, but the engine and transmission had APP 1 and 2 correlation code, and that was where I found the bulletin for the, not a bulletin, but a tech tip on water intrusion. And then I had some U codes for class 2 serial data circuit. And I don't know that, it did say for the class 2 that battery voltage to the module was normal for it to set that code, but I don't know. I don't know. Having it not act up is not good. And
so, but it was the APP, not the TPS.
Yeah, APP.
And that does use two separate circuits. On the last GM, the throttle body used the same 5-volt reference, but the APP used one of each leg of the 5-volt reference.
Oh, do you remember which relay? It was like PCM control, maybe? 77. So it'd be this one. Oh, yeah. Oh. Look how bad that one is. That's the PCM control relay. That's what we had. Unfortunately, me unplugging it.
You fixed it.
We ain't ever going to make it do it.
If it's dropping out on the PCM side.
Right. That's pretty bad, though. You know, that's got a good bit of corrosion on that. And what was the other one? I pulled the relay apart and it was all inside of it, too?
It was inside the relay, was all, yeah.
That is I'm pretty sure, the PCM relay. Yeah, they all have it, man. What a junk-ass design for those relays to be corroded like that.
Hey!
I dropped it and fell all the way down. This one's really bad too, man. They're all bad. You know, I'm kind of breaking a cardinal rule by pulling these apart and looking at them. Recreating the fault was going to be key first, and now it's just not going to happen. I remember the last one. We had throttle body codes, right?
I honestly don't remember.
I think we did. It was a relay that
it wasn't turning on.
It was a relay that was powering the engine computer. The engine computer had low voltage, and then it was flagging the throttle body because the computer compares voltage to one leg coming into the other, and it was the leg that fed power to the throttle body. And it was the PCM relay, and it was pretty corroded. These ones all look good in here. These guys. And these smaller ones, what are those ones for? Fog light. 74 is horn. 79 is the run crank. So that's these three. Those ones, the ones that look different. PCM control relay 77. Yeah, that's this one. And that's really corroded. I'm gonna switch it with a different one. Give this back to the guy. This is the AC clutch relay. We'll switch that one. No, that's the run crank relay. 76 is the AC clutch. Where's that? Taking those two relays, putting these two over here. So I switched those two, 80 and 81. 80 is the air solenoid and 81 is the powertrain. Oh, I didn't want to do that. 81's, this is the powertrain relay. Oh, so 76, the one below that is AC clutch. We'll move that one up there. Danner, I'm switching relays around here, buddy. I moved the corroded ones. Now I'm messing myself up now because of that. I did. I switched it with the AC relay, and I moved the good one from the AC relay up to the powertrain one. That's a powertrain one too. That's 81. And 81, it says power/TRN, so powertrain, I imagine. These two, 75 and 76, I switched those. That's, wait a minute. Sorry, 77 and 78 is these two, which is PCM control and run crank. And then, what are these ones? 87 and 88 or what? HVAC and RAP accessory relay. Which ones are corroded in here too? Yeah, these were too. 87 and 88 is HVAC and RAP. 88 is this one. I want to change that one. Well, I did some Swaptronics, Danner.
Swaptronics?
Yeah, with the relays.
I'll drive it randomly if it breaks, I'll tell you.
Okay, that sounds good. We're gonna. It might not be a bad idea too to maybe research that that bulletin a little further with the APP code. I did have APP 1 and 2 correlation, not TPS, but APP. But I also had like class 2 data high and low in the tire pressure. I had in the anti-lock brake module, I have lost class 2 communication with the ATC. I don't know what that is. Automatic throttle control, maybe? Lost communication with ECM, lost communication with BCM. That was in the ABS. I mean, maybe it's the P2138 that is the only one we're dealing with. Let's see if we got some bulletins on this. Yeah, I have a TSB for this body harness connector, and it is a little bit wet right there.
Where, under the dash?
Yeah, and I found a bulletin on that. Let me come back to that. Hold on. This might give me a little bit more info than the Snap-on version. It says 2018 prior GM passenger cars and light-duty trucks. This isn't any more helpful at all than the Snap-on one. It's like word for word. They copied it. It says the condition may be caused by water intrusion into the instrument panel to body harness connector, which carries the APP sensor signals to the ECM PCM. This water intrusion results in voltage differences between APP 1 and 2 that exceed a predetermined value. And the correction is lame because it's not specific to this. It says 2018 and prior GM passenger cars and light duty trucks.
I think it was the same bulletin. It was on that Cadillac, wasn't it?
I don't know, it could have been. Verify aftermarket equipment is not electrically connected to the APP. So I need to find out where this connector is. I'm gonna at least try to do this before I say I'm done. To identify at least where that connector is that they're talking about. Locate the IP2 body harness connector, which may be located in and around the left-hand kick panel area or inside the instrument panel. I'm not pulling the freaking cluster, depending on the vehicle and model year, so refer to schematics. Great. So the IP2 body harness, all right. Let's see what we can find. Well, that's not helpful. That's just the instrument panel connector itself. That's not the body harness. So what I'm looking for in this diagram would be like A and B. That'd be a connector. They're not really showing me what I want to see on that. They're not showing me the connector. Here, check this out real quick. This accelerator pedal, according to the bulletin, the wiring for the accelerator pedal goes in through a body harness connector. And normally I thought these diagrams would give you like when it goes through a connector. It doesn't, man. This is
Can you
going
find the GM,
this is going straight to
like the factory diagram.
That's what
the last one I was looking at.
That's what I need, huh? Connector end views. That might be what I want. There we go. Danner, look at this factory connector. They don't show it there either. There's your APP on the factory one. It's going right to the PCM.
Wow.
They don't show like...
The bulletin showing a connector.
Well, I mean, the bulletin did say that
there's a connector.
It said it goes through the instrument panel to body connector. But like you look up the instrument panel diagram and it doesn't show anything either. But maybe I'll just do a visual on the APP and follow the wires and see if that leads me anywhere. I know these relays that are all corroded, you know, the longer we go into this, the less I want to scrap it. That's always the way it is. It's like all of this is, I would have stopped a long time ago had we not been filming. I'll look at this connector end views one here in a second, but the code, ignition off, observe APP, observe freeze frame failure records. I didn't do that, I should have. Turn ignition off, disconnect the pedal. Measure voltage, no, nope, 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 nope. I don't see this connector. It's not really wet under here. Just a little bit on the floor, like right in this corner, but even that's not much. That's just winter driving, I think. We do have some aftermarket stuff here. I'm done. I'm done, Caleb. Another intermittent one that maybe we'll use, maybe we won't. Hopefully we'll get an update on this. I'll probably update you guys just remotely, swap some relays around, which really wasn't a good idea because we never saw it do it, so we don't know if it was a low voltage problem like the last Hummer that we looked at. We just don't know. What we showed today really isn't the right way to handle an intermittent. I think that it's always important to duplicate the fault first before you start touching things. And you know, when you deal with something like this, what we did wasn't bad, you know, in a shop environment especially, because now you can at least tell the customer you did something and you know, give it back to them, let them drive it. Let them drive it, see what happens. And you go from there. That's kind of our direction with this Hummer. We're stopping here. I'm stopping here. I'm not going any further. And again, I'm hoping that we get a update for you guys on this. And if not, chalk it up to another intermittent that maybe you learned something, maybe you didn't. I don't know. Hopefully you did. So thanks for joining us. Hoping for an update.
Oh, you'll get one.
We gonna have one? Yeah. Okay. Well, that's good. Then part 2 coming up. So Caleb and I were talking off camera, and we said, as we're fighting other intermittent problems today on other cars, our thoughts were, let's at least give our community something on this Hummer other than sending it back to the customer. Damn. Should go over there and film him doing that for a second. Get closer so he knows.
What, you want me to swear too?
He's just making all kinds of noise. Nice, he got it. All right, we're gonna do the EVAP Vent control circuit low fault code just because it'll give us something, and then we can, you know, produce at least this part of it, maybe do a follow-up video for the rest of it. So let's look at this EVAP Vent control circuit. Should be pretty straightforward. It's a hard fault. It's doing it all the time. Those are always our favorite. Vent solenoid says open. That's just the command. Some of these would give you like the vent valve state. That's just what the command is. All right, so ScannerDanner is not going to help us. Some of them it does. Where is it? Should be here. Oh, it's rusted to shit and back. Okay, this thing's so rusty that I really need to I'm just trying to think the best way to troubleshoot this. I want 2 voltage readings. Here, I need you to get a shot of where this is. I feel like we should just quit.
Why?
Just because I'm frustrated now. Everything's in my way. This rusty ass.
Couldn't tell.
I'm just, things are just not going well. Look, I'm gonna find a good ground under here. You need to run me a jumper wire from the front to the back here for me. This is ridiculous. There's no way. All right, so the orange wire, I think that's orange, should be the feed to the solenoid. We should have 12 and 12 with this circuit off. This is a ground side switch solenoid. We've done a ton of these. And I just gotta pray for a good ground. Oh, it's not too bad. I got lucky. All right, 12 volts. And then, let's see what this one looks like. That's the white wire. Got nothing. So that's an open solenoid is what that is. Let me unplug it. See if we have any kind of bias on this circuit. No bias. Last test is gonna be test light and we're done. So what 12 and 0 means to us, 12 volts comes in, should be 12 volts coming out, wraps through the coil, comes out, should be 12 until the computer grounds it and drops it to 0. So what we're gonna do is check the computer circuit. We already have one there. Put the test light on the pin. I wanna put my test light in between these is what I wanna do. We'll do this differently. I never front probe a connector unless I have the right adapters, ever. End up spreading pins. And what we're doing is just putting our test light in series here. That's all we're doing. Just don't want the weight of this pulling on my connector. So I wrapped it there. Test light is now in series. Take the scanner in a bi-directional mode. Functional, output controls, EVAP purge seal, EVAP vent solenoid on and off. So there is a code. I might have to clear it. It might not energize this with the code in memory, but let's try it. There we go. Turn it on, turn it off. So that circuit, that proves that that 0 volt reading we had was not a short to ground, because a short to ground on the control wire would be a 0 volt signal, and in which case with it off, which I have it check marked off right now, that light would be on right now with the 12-0 we had. If we had a short to ground on the control wire, that light would be on right now. That 12-0, it's not a short to ground. The only option for our 12 and 0 is an open in the coil itself, which is what we have. And the fact that I can turn this on, make that light, says the control wire integrity is good, says my feed is good, we are done. This is an open solenoid. That's it. That's all we needed to do. And what we can do now too is, now we have to start the car to set the fault code, I believe. Let me go to the codes menu and clear them. And then display codes, all codes. Now, if I take my the test light's acting as a good solenoid. If I take the test light out of there, this should flag now a EVAP vent valve code. But I have to crank it and start it for that to set. So that's just another way that that can be done, is code setting. You can use, if you didn't have bidirectional controls, you can unplug the solenoid, put your test light in series, like I have here, and then clear the fault codes, and then restart the car and make sure the code doesn't set. That's a valid test as well. So if you want more on EVAP vent solenoid testing or output controls, this will be chapter 3 material in my classrooms and in my playlists, both on YouTube and on Premium. So if we end up putting this on YouTube, you guys can find a lot more in my Chapter 3 playlist right here on the channel. Just go to the home page, go to the playlist, look up Chapter 3. It's output solenoids and transistor drivers is what I have it titled as. And I have a whole bunch more EVAP vent valve faults on GMs and on other cars, other outputs. It's all the same type of testing. So at least we got something out of this one, right? Faulty EVAP vent valve. Hopefully the relay swapping took care of things. We're gonna give this back to the customer and maybe, again, as we said before, have an update for you guys. So thanks for joining us. We'll see you soon.